Okay, hello and welcome to today's live webinar, The Tools You Need to Accelerate Time to Market. I'm Winston Lazar, Senior Product Marketing Analyst here at Itron. Before we get started, I'd like to take a minute just to review the screen in front of you. You will notice that there were several windows here and a menu bar at the bottom of the screen that will allow you to customize your webinar experience. You can enlarge the presentation window by clicking on the Maximize button in the upper right-hand corner of the presentation. Please also note you'll be able to ask questions of the presenters at any point throughout the presentation. You'll see a Q&A window on the left side of your screen. Feel free to enter your questions as they come up. We'll try to address them as they come up. We'll conclude the presentation with a brief period for Q&A, during which time we'll answer any questions that weren't answered. I'll go ahead and address the most commonly asked question, which is yes, this webinar will be available on demand for replay. You'll receive a link by email after the webinar concludes. Okay, so please join me in welcoming our first featured speaker today, Todd Thayer, Director of Technical Enablement and Product Management Group here at Itron. Later, we'll welcome Sam Neary, VP of Business Development at eLikens. With that, I'll hand it over to Todd. Thank you very much. Thanks for joining us, Todd.
Yep, thank you very much, and thanks Sam and Mark for participating in this and sharing their experience. Looking at the list, I do recognize a lot of you, so this is here to get the value you need out of it. Really, we've had questions around how to find material and how to use the resources that are available. So I certainly want to answer those. Feel free to chime in with questions as I go. And also feel free to questions for the other group members are fine as well. We like this to be as sharing as possible. So yeah, what are we going to talk about? So I want to give you a quick overview of course the developer program, why it might bring you value, a quick review of developer kits, and then really the bulk of this is going to be a walkthrough of resources that are available on the portal and how to get what you need out of it. All right. So why come to us? Well, obviously gaining access to our customer base, and we want to enable our partners to do that. Silver Springs, prior to the acquisition by Itron, most of you probably know that Itron recently acquired Silver Springs. So prior to that, Silver Springs itself has got nearly 27 million endpoints deployed between the utility and smart city space. When you bring Itron into that, there's 90 million endpoints on their side, of which somewhere in the range of 20 to 30 million are on AMI networks. So when you add it all up, you got 50 million endpoints if you develop a solution that's deployable in smart city, industrial IoT, or utility space. It's quite a big market. Obviously, we strive to be standards-based. We certainly believe that our success depends on our partners' success, and having open standards is critical to that in our effort. We strive to be the best that uses those standards. The flow, the process of engaging with us, of course, is if you don't already know who we are, there's plenty of discovery material available through our developer portal. There's tutorials, there's video tutorials, there's background information on the technology, the meshing technology and the endpoints that you've got. There's reference applications, source code, lots and lots of stuff, and we'll walk through that. Of course, developing solutions comes with developer kits, and we're going to talk about that in a minute. There's also, a tool called Starfish Studio, which is really built over a data platform, which is kind of a cool tool. I'm not going to cover it today. I'll cover it in a future webinar. But ability to simulate devices with any measurements and any device types, simulate them and write them down into a data platform without having to build a device. You can then write an application over the top of simulated data with the same schema that your end device would have, and that's what we call the Starfish Studio. And then, of course, as you finish your development effort, we want to help you go to market. We will give you, certainly product support, product positioning, help with product marketing and sales positioning as well. All right, development kits. I get quite a lot of questions. I get questions a lot of times about how do I get on? How do I use the mesh network? How do I get transport from some remote, hard to get place to the back office or my back office software, and how do I get started? It seems confusing. Well, really, it's whether you're going to integrate and plug integrate a device into your own device, or would you rather go with a plug-and-play solution? Decisions that go into that, of course, are what's the volume, what's the end volume, the unit volume you're talking about, what's the cost sensitivity, is it battery powered or constantly powered, and are there significant compute requirements of the application? High volume, low cost would be an integrated effort, and a plug and play sort of an exercise with, say, our IoT router would be where you have a full powered application, you have edge compute requirements, or you need to connect maybe networks of networks. We need to connect another network into our network. You would choose the router. What kits are available through the developer portal? Most of the people, I see the developers on this webinar probably have some experience with this, but this Milli Shield, of course, is our Milli, which is an RF mesh IB6 battery operated networking card. And the DevKit is actually mounts the NIC on an Arduino shield, so that any of the Arduino technologies can be plugged into that same shield. You can go buy any Arduino board, and it would just work. Of course, you can use other microprocessors and breadboard it up with this DevKit. In order to leverage that DevKit, really it's the sensor, a smart sensor, would have a microprocessor implementing a CoAP server on the sensor side, and communicate with the NIC through the UART. To use that and to get the backhaul into the back office or to your cloud software, you would need an IoT router with WAN mode. Some people had used some of our mini APs, which have been discontinued, and from here forward it'll be an IoT router, which would connect through Ethernet instead of cellular like the mini AP did. Of course, the IoT router then is a development environment with a full Linux platform on it, leveraging Ubuntu's Linux distribution in a configuration called Snap that manages the deployment of the applications, and also the segregation of data and access controls and things. So that's the IoT router. The Milli, we also offer, for people who have proceeded far enough with, say, the Milli DevKit to be ready to integrate onto one of their boards and start doing designs through the portal. We can also offer you, Milli modules to do board layout and actual control once you are ready to move forward on to the next steps. So we will offer those through the portal as well. Where are we available today? These are the countries that we have certification of the DevKits. Asia Pacific, Australia, Singapore, most of the EU, all of the ETSI regulatory board countries are covered. In North America, it's US, Canada, Jamaica, and Saudi Arabia is planned here within weeks, and then Israel and UAE are on the radar to get regulatory approval, so the kits will be available there as well. Okay, so now I'm going to spend a few minutes just kind of walking through some resources. Let me switch over, and I'm going to share it to a screen share of the actual portal. And if there's something specific that you'd like to understand how to find, please again chime in if you'd like. Otherwise, I'm going to walk you through some of the things that I got questions on. All right, so this is the portal that you're seeing. It is developer.ssni.com. Of course, visiting there is plenty of content available to be explored before you sign up. If you want to just explore, certainly the main landing page. There's plenty of resources and jump-off points here where you can get to all kinds of all kinds of resources and tutorials. The landing page is plenty. Then there's also drop-down menus, and you can use those drop-down menus to explore. I'm actually going to sign in so I can get access to more. The portal itself is tiered in terms of access control. That certain amount of information is available to the open internet, and then other information you actually have to have created an account and have logged in. And a lot of that is we want
Hey, Todd. Let me interrupt you here, and just before you log in and start digging into the portal, let's take a few questions because we've gotten a few in from the attendees so far. So first question from Rob Beatty. Rob's asking if we have the original DevKit with the mini AP and IoT Edge router, what do we need to do to switch over to the new IoT Ethernet architecture back to the Starfish Dev Network?
So yeah, Rob, good question. So if you've got a mini AP now, really all you need to do is get one of these IoT router WAN modes, which are being released here probably early April, end of March, early April. All you got to do is get one of those. Your device, your Milli kit would connect to it and just shut down the mini AP. It would route through Ethernet with your same tenant. We would provision that IoT router the same way we did your mini APs. And what else? What else do we have here?
Okay, next question is the mini AP SIM card locked into the wireless carrier? Can I insert my own wireless carrier agnostic SIM card for coverage improvement reasons?
I'm assuming Jay, that's Jay Evanesian, I'm assuming. And Jay, so struggling with yours, the mini APs are really delivered with a AT&T, and it can be an AT&T roaming SIM card, but it's an AT&T SIM card. I know Eric is trying to chase down whether that's even possible. I know you were having some cellular connectivity issues, and I don't actually know the answer. We're trying to figure out whether another SIM card can be easily inserted into that, or whether it's going to be more headache than it's worth. We do have multiple carriers in our real APs. I just don't know what the limitations are for plugging in a new SIM card and whether it will work. And I'd hate to go for you chasing unicorns on that one if it's going to be a lot of trouble. We'd instead probably just get you an IoT router with Ethernet connection instead. Anything else?
Okay, thanks, Todd. Let's move on from here.
All right, so I'm going to sign in. Most people on the call, I believe, have probably already signed up. I'm going to skip that phase, but it's pretty simple. All right, signing in. Let's let that come up. When you land in a My Account overview area with multiple tabs across the top. The farthest tab on the left is where your devices lists are. Here's where you would find devices that you've ordered, along with the status of those orders, and perhaps any MAC addresses or serial numbers that are appropriate. When it was shipped, an appropriate, if it's shipped by if it's ordered through the normal process and shipped by our fulfillment team, then you would have a shipping tracking number available to you here as well. All the way on the right, there's a couple of green buttons. If you need to initiate an RMA or a return because of a defective device, you've got an RMA button to initiate that RMA. And if for some reason you've decided to retire a device, or an order is never going to get filled, you have the ability to just retire a record as well. On the next tab, which is labeled Data Platform, that's really more about a concept called tenancies, where the network that things are developed on is a multi-tenant network where we need segregation of data both on the network itself and the end devices and the data platform. So there's a concept of a tenancy. When you sign up for an account, you get your own personal tenant. You have the ability to switch to another tenant and join into a tenant as a group. You can either do that by typing in the tenant name, you have to know the tenant name, and we did that on purpose so we wouldn't have people just trying to join anybody else's unknown tenant. Assume that you know who you're trying to work with. And then there's also the ability to invite members, so you can send an email to invite somebody to join your tenant, and that would automatically grant them permission to join your tenant, and they would have a link that would be emailed to them. All right, there's company management in here. If you have multiple people in your company working on something, they can all typically access any shared information. You know, if you're sharing documentation and maybe you're working with the Silver Springs or Itron project management office, there's the ability to share information back and forth, as well as support tickets. People from the same company can see each other's support tickets. And there is the ability to put a gatekeeper in here, so an administrator who would have to admit people to join your company, so somebody couldn't just sign up and join and get access to your information if you did not want them to. And to do that, you would just click that membership approval required. Next, account settings. Basically, it's what you think. It's all of your personal information. Here's where you would come to update it. I would like to call attention to there's an area of interest on the account settings that you select an area of interest when you sign up, and that customizes the material that's filtered through the portal. Like it tries to, the attempt here is to curate the experience so you get the material you need to make it as clear as possible and filter out the stuff you don't care about. Now there's only 2 in here today, but within a very short time, other use cases and topics will be integrated into this portal, things like distribution automation use cases, specific smart city use cases, and you might want to curate what you actually presented or explore other areas of interest that aren't necessarily in your primary one, and you would do that by selecting those here. Client ID and secret is your API key authentication, so that's where you would go to get your authentication credentials. And then the last but not least is support tickets. That's where you would see any list of any tickets that you have submitted, and there's the ability to filter that by, say, a company or a tenant. Remember, I said there are tenant groups and there are company groups. And tickets can be created against either one of those groups, and anybody in the company or the tenant would then be able to see them. You have the ability to filter those here. Forums have been, a lot of people have been using forums. We do actively monitor those forums. They seem to get reasonably good use. We do have people who try to weigh in, but I also see other users weighing in with their experiences, so that can be a very good place to get some information or to get help if you need it. And then of course there's an FAQ. FAQ is, most of the questions that come up, like how to get started, how do I place an order, how do I get a client ID and secret, your standard questions. There's a whole FAQ section that's available to you as well. All right. You want to pause here for questions? Do we have more questions, Winston, or should I move on? It's a decent break point.
We've got some questions coming in, but why don't we move on and we can address those, waiting on the specific follow-up to the questions before we do that.
All right, sounds good. So let's talk about the resources, the material that's available. So certainly at the top, you've got these drop-down menus. The first one about the platform is really that discovery. It's really an overview of the technology, right? You've got an overview of the meshing technology. You've got hardware that's available and some descriptions about it. And then, of course, data platform, what's available in the data platform. So that's the discover, really, who we are. It's background. Most of you probably have done that, are reasonably familiar. Most of the people that are on this call are reasonably familiar with that part. And if you're not, please get around there. So I'm going to spend more time on the resources that are available. So underneath developer resources, we've got, I would say the best place to go for finding information. A guided tour is the guide to getting started. So I'm gonna walk through this. So the guide to getting started is kind of broke out in terms of me as a user trying to get value out of this developer program. How do I find what I need? So it's really built out in questions. I'm looking to connect hardware or devices to the network. Next topic is I'd like to connect another network. So I've got a network of networks solution, or I have an edge compute application. This one also happens to serve if you have a modem replacement. That's really a network of networks. So that use case is a network of networks for the most part. Next would be I have a software application that I want to put over the top of data that comes off of devices or off the network. We have plenty of partners who really just have software applications like analytics applications and things that they build over the top of the network. That's the last one. And then of course I've got end-to-end connectivity and need to understand the whole end-to-end. I'm going to just walk you through one of these. So I've got devices and I want to get them on the network. All right. So again, you'll recall that my DevKit layout was split up between integrated or plug and play options. Again, it's the same conversation. Do you have high volume, low cost, small footprint, or do you have edge compute applications with less cost sensitivity, and or you'd like to do a quick proof of concept. Sometimes using a plug and play device without having to do a device integration may be quicker and easier, and you may want to go down the path of say an IoT router. So the right side of this, of course, would be take you to down the IoT router path. Left side would be the integrated path. Let's just follow up on this battery powered. So let's assume I've got a battery powered application. I follow that, and what I'll see is help on what hardware do I need, what's the interface connectivity that I would get out of that, and then all of the material and resources are collected in one place with links to help you be productive on that path. So if you're going to integrate a Milli or a Milli DevKit, this is really a good set of resources, a very complete set of resources of tools and how to get going and how to get started with direct links to them. All right, so that's really the getting started. I would say next most interesting are APIs. So what APIs are available underneath developer resources?
Before we jump into APIs, can we just answer a question that's come in? The question is from Jay from CNI Guard. Can you please briefly explain the following environments: data platform POC, data platform production, Starfish production network, and Starfish staging network?
Yeah, that's a good question. So the network. So I think we're probably here in a decent diagram. So this diagram is not a bad sort of broad overview. So our data platform is actually hosted out in AWS. So it's separated from the network itself. The network
lost
itself
your screen share. Jump to country availability now.
Yeah, let me get it back up here. It does not want to record. There it goes. All right, it's coming up. I apologize. So there are different networks, and then there are different data platforms, and they're really separated from each other. So a network, the network in the upper right of this diagram, there is our public networks that we have. Network as a service is called Starfish. So the network as a service, we have Starfish Stage, which is where the developer program lives. And then if you use a public network for an IoT application, that would be promoted to our production, Starfish production network. There are also all of the private networks of, say, utilities and cities around the world that have bought private networks, and those are separate from that. There's really, the data platform itself lives out in Amazon AWS, and we have 3 instances of that data platform. One is called a POC, which we use in very early testing, and none of you probably get exposed to that. One is our Starfish Prod, which is, our Prod data platform, which is where all of the production data and all of the developer program data goes. So that's really the difference. We've got a Starfish stage for development, Starfish Prod for production deployments, and that's the network. And then we have a data platform proof of concept for early things. But really, the only data platform you get exposed to is our production data platform. I know there are references to it on the portal, and that's because certain people have used some of those other instances for various things, and we wanted a reference. For the developer, I would say for the developer program, think Starfish Stage and Prod Data Platform. Okay. All right. So let's APIs. What APIs are available? There are APIs to access data that would get written to a data platform for long-term storage or analytics applications. And then there's another set of APIs which is direct to device across the network, which is a CoAP API, which is really implementing the CoAP RFC, and they are both authenticated through the same mechanism, which is the API gateway. So the same client ID and secret would access each of those API paths, and you would get to say a client ID and secret to access a token. And the security model is you first go get a token using your client ID and secret, and then that gives you the ability to call either of the API sets for some limited period of time. That token expires and you have to go get a new one. Standard OAuth authentication. All right, next topic. There are reference applications. So there's reference applications both for a MILI DevKit or a MILI application, as well as an IoT router. These are reference applications complete with setup instructions, detailed setup instructions, how to get it up and running, as well as source code. So we've made source code available to give people a starting point. This is the MILI DevKit reference application. It's a temperature sensor, simple temperature sensor, broken into 3 parts. You've got the Arduino code written down on the Arduino microprocessor, and again, you could use any other coprocessor, but this particular one is done as an Arduino. In the middle is an application, a middleware application that uses the CoAP RFC or the CoAP API to pull data off of the network, and the data platform API to push the data to the data platform. And then the last part of the reference application is a user interface-based plotting application to pull the data off of the data platform and plot it. And those, the detailed instructions for each of those 3 parts are supplied, separate pages with detailed instructions how to set them up, and of course links off to the GitHub repository. So notice right here, all of the open source or the source code has been posted to GitHub, and you can go download that and replicate it. One of the last things I'd like to sort of bring to your attention is something called Document Center. So there's lots of content built out on all the web pages of the portal, but as you can imagine, there's a ton of information that is not just built into a web page. It might be source code or templates. We deliver source code templates. There are data sheets. There are schematics, other things that are available in multiple kinds of ways. So that's called Document Center. Underneath Resources Document Center, it's really just a tree structure that you can expand to find things that you might be interested in. If I go down, excuse me, if I go down and just select one of the folders, I'll see the documents that are available. Like here, we've got a detailed data sheet on the Arduino DevKit, which is just a PDF, as well as schematics of that. And over on the right side of this, I see two arrows, so I can download it. If you get deeper into it, you'll see here, there are code templates for other microprocessors on millis. You may actually see, you might see some content. If you don't see, I don't know if I can find one. If you don't see a, oh, here's one. So if you don't see an arrow in that box, that means there's a piece of content there, but you don't yet have the permissions to access it. And we did that so you would know what else was available, and you could work with somebody at Silver Springs or put in a request to get access to it. Like, there are certain pieces of content in here that are a little bit more secret sauce than we'd like to just open up to just anybody. Maybe don't want our competitors to get a hold of it, but we do want our partners to get a hold of it, so we reserve the right to just restrict those. If you see things in here that you would like to get access to, shoot a note into support or work with the person you know at Silver Springs and see if they can grant you access to it. All right. And lastly, if you're ordering a kit, here's where our dev kits are. You click the dev kit button. There are starter kits, which has everything you need to get started with a milli and an IoT router or backhaul. There are also the ability to order each of those parts individually. Be sure that when you order that you're ordering the one that's appropriate for your geographic region. There are different there's different hardware and RF filters, and you might want to be sure that you order the right equipment for your geography when you do so. All right, I think that was it. I do see a few more questions. Should we answer those before we move on, or I don't?
Yeah, sure. We're running a bit long, but last question is, where are CoAP client and CoAP server running respectively?
All right, where are the CoAP client and CoAP server? So let me pull up see if I can find you a decent diagram to show that. So all right, so this diagram here would show the full flow path from device to user application. So in a CoAP implementation, the sensor up on the top left of this diagram, which has a microprocessor on it, is written as a CoAP server. That behaves as the server. There is in the middle of the whole process, well, let me jump to the end. So you got a CoAP server on the upper left and a CoAP client really on the user application. So the user application could, it could be written as just a CoAP client, or it could be written as a data platform client. Let's assume that it's a CoAP client. Well, that then requests data from the server. In between the server and the client is a proxy. The gateway actually behaves as a proxy and a traffic cop for all traffic. So the CoAP gateway in the middle, it really behaves as a true CoAP proxy. It proxies your requests down to the device and manages the requests down to the device, so that maybe there are multiple clients trying to get at the same device. It will only do the same command once, and it will serve that information up to all the clients that do it. Did that answer your question? If not, please ask a follow-up. What else, Winston?
That's it for now. Why don't we move on to the Likens team?
All right, let's move on. Sam, Mark, thanks a lot.
Thank you, Todd. Thank you, Winston. Good afternoon, everyone. Get to the slide. There you go. Do you see my slide, Winston?
Yep. Thank you.
Yep. Okay. So let me start. I'm going to speed up a couple of the slides, introductory, to get back on time. Thanks for having us on this call, Itron, Silver Spring team. I'm going to go through a few slides introducing eLikens, to our product, what we do, who we are, and jump a little bit into our cooperation with Silver Spring platform, DevKit, and what we have experienced, and show some examples of application around our product. So our mission at eLikens is really pioneering the smart sensor network to enable air quality sensing through our solution, which includes data fusion, cloud models, and analytics, with the ultimate goal of providing a safer and eco-aware environment. Company was founded in 2014. We're based in Grenoble, France, and Sunnyvale in California. Our R&D location is in Grenoble, France. Company about 19 people, venture funded. We are fabless, and our complete solution consists of our smart sensor that we have created, which is behind this whole solution, our data fusion and our software algorithm. Our technology is patented and number of patents growing, and the key solutions we provide is what we would like to call the most disruptive NDIR, CO2 and CH4 gas sensor, along with solution for smart city air quality and gas leak monitoring station. We have won quite a few awards in many different consortiums and presentations we have attended. So next slide, what is our sensor, which is really the IP behind it and some of the things we're doing. It is the most disruptive NDIR, CO2 and CH4 smart sensor. It has our integrated MEMS structure inside infrared, which integrates also our cavity, that is our patented design, along with some signal processing that allows us to really get very high efficiency, accuracy, and one of the lowest footprints for such a sensors in the market. It is a dual channel sensor, a very small footprint, very low power, less than 2 milliwatts, no drift, and has a digital interface which makes it easy for our customers and our clients to design this thing within their platform. Our solution is a complete solution. What we mean by that is that we have our sensor that you saw on the previous slide, CO2 and CH4 today. We also have our air quality station, both for indoor and outdoor, which includes our sensor plus some of the other off-the-shelf sensors, and the wireless connectivity. We have luckily and fortunately worked with both Silver Spring and Itron in the past, and the merger really just made our collaboration even stronger. It's a very compact and low power design. That's on the hardware side. On the software side, we have our data analytics and data fusion engine that runs on this hardware platform that then connects and provides via API to our cloud engine that our clients, they can access to all these air quality data and represent it in many different ways. Let me show you some example in the next slides. The market segment we're present in and we're working, one of them is smart city with all the outdoor air quality pollution stations, gas leak monitoring for all the methane and utilities and some IoTs, industrial and safety, smart home IoT, indoor air quality, HVAC, where they use our sensors for air circulation and higher efficiencies. And coming later this year, early next year, it's going to be in the automotive in-cabin air quality. So jumping into the smart city offering that we have both in the air quality solutions and the gas leak detection. So in the middle of this picture, you see eLikens Space, which is our hardware and our software as described in the earlier slides. On the left-hand side and the right-hand side, you see basically all the cloud model and public domain availability. So what we do, we use this cloud information, being fixed environmental data, weather forecast, emission sources forecast that are available. We use those as an input within our hardware-assisted air quality solution, and it allows us to really come up with think of a coefficient of accuracy and calculation that allows us to provide air quality sensing at street level down to 10-meter accuracy. The data is then provided as an output via API that all the service providers, smart cities, clients, customers, they can use that to represent it and use it for mapping, detection, monitoring, forecasting, simulation, and so on and so forth. What is our differentiator in this? There are a lot of cloud model, and one may ask why an hardware-assisted model. So what you see here on the left-hand side is data, no data assimilation, meaning only cloud models available and no hardware-assisted data assimilation. And on the right-hand side, you see where eLikens station is installed in the city, and it gives you the live data that is captured. What seems to be a very good air quality and all green is actually when you look at the live input turns pretty much yellow and kind of poor. So we use basically a dispersion models along with our sensor assisted that comes from our hardware, and that is our differentiator. We trust the model, then prediction that are on the cloud, that is available to everybody, and we correct that bias using our real-time sensor data. So the differentiation you get in this is that one of the important ones, accuracy. Typically with models, you're at about a 500-meter accuracy with air pollution and then just kind of a pollutant. We can bring that to 10-meter accuracy, no real-time validation, and we provide an all-time validation along with our hardware-assisted quality stations, and no unpredictable events with the models. And with our solution, you really have a capture real-time events. So if there is a fire, if there is an accident, if there is a congestion, all those unpredictable events, they're going to be captured, and you get a very high accuracy and live air quality station output that allows you to get the adequate and correct pollution output out of this area. What the data looks like when you put it on the map, this is just an example, one of the rollouts we've done in Paris. So you can see from the API and data interface, you get access to all the different gases, pollutants. You have all the concentration. You have graphs that you can look at historic data 3 days back and also forecasting 3 days forward. So all of that is basically available through the API and can be exposed in many different services or many different applications that our clients, OEMs, they would like to implement and provide. On the CH4 side, gas leak detection, again around our own MEMS-based sensor NDIR, allows us to create this CH4 leak detection and gas leak detection and monitoring. Some of the value we bring in is that because of the low power and small footprint and the lack of drift and auto calibration that is within our sensors, allows us to have a very long battery life, which enables the OEMs and the customers to have products that they sit on the wall for 5 to 10 years and not being able to, not need to update or change batteries. We have done many different IoT connectivity, both with Silver Spring and Itron radios. It's a very configurable platform, so the OEMs, they can detect and they can adjust the alarm level for gas leak detection and basically use that with a very fast response for any kind of a services they want to provide behind it. Move on to the next slide. Why choosing and why working with Itron and SSN? So when we look at smart cities and entering into that market segment with our solutions, obviously, and from what is in the market today, air quality and gas leak monitoring, we get a lot of demand, and we get a lot of applications and future projects and RFQs coming for smart city applications. These projects, they typically to be multi-pieces and multi-stage and implemented with many different partners. Some of the key players in this market driving this demand are actually utilities and service providers. And from our investigation and working with these utilities and service providers, it's very important to have a very strong partner that has experience, that has ongoing business with these utilities and history, has installed networks and established business model that really enables the smart city rollout and utilities to expand services. And Itron and SSN, they've been pretty much the leaders in that. One of the other reasons is really the flexibility and the complete solution that is provided by Itron. Throughout all these different projects, you get the requirement and that they want wired, wireless, low power, low cost, high availability, low availability. And as Todd covered earlier in the presentation, the breadth of portfolio available from Itron really enables us to satisfy and address quite a few of these demands and each one of these RFQs and enable a faster time to market and easier rollout of the products once it's designed in. Next slide to show you an example of what we have gone through with the DevKit integration from Silver Spring. On the top side, what you see is kind of a block diagram of what we have done within that integration. So we received a mini DevKit along with mini AP via UART interface. We interfaced our air quality station to the mini DevKit. that then was connected to the WAN and internet and through our cloud. What we did on the software side was also pretty easy integration, but some work. The UART availability within the Arduino made it very easy to integrate with the hardware. We then were able to quickly connect through the DevKit Mini AP through the WAN interface. Our R&D office being in Europe, the interface wasn't available in Europe for Mini AP to the WAN, so we had to do some work to get that done. And then finally, the co-op protocol was a pretty straightforward messaging and conversation between our box and the cloud to our application. It was fairly easy, and we got it up and running in a very quick fashion. With that said, there were some challenges, but nothing was a showstopper. To highlight some of the challenges through our experience and what we have done to solve them, we talked about one of them at the time we did this project. The Mini AP wasn't available in the Europe region, so the last step of that integration, we had to come to our US office to make sure that we can get the integration finalized and the communication up and running and tested. The second one, we worked with this environment inside of the corporate networks, and what we experienced some intermittent messaging and stability. And part of that was actually, which we realized and learned at the end, is that within the corporate networks, the firewall setting doesn't allow you to have a very easy and very open guest access network. So when we moved out of the corporate environment and we did it outside, everything was plug and play and worked in a very smooth way. I believe this has to do with a lot of the firewall setting within corporate networks and the DHCP ports and things like that. The last one, which we haven't gone through ourselves, but we know that the job needs to be done also. Today, by integrating the DevKit, the co-op server is running and working on the Arduino platform. So in the final product design that we go through with an OEM or a customer, we need to also have the step of, as Todd mentioned earlier, to have this co-op running inside of our platform. It doesn't seem to be a huge task, but it's something to keep in mind that in the final version, replacement of that Arduino and that core processor, the co-op needs to be ported and also supported inside of the platform on a microcontroller or some other piece. Show you an example of some of our products. On the left-hand side, you have the CH4 gas leak detection, and as a reference, the size of the sensor right below it. And this one, we integrated the Silver Spring Milli radio that we tested, and we're working with some clients today. On the left-hand side, sorry, that was on the left-hand side. On the right-hand side of the screen, you have the air quality station and the CH4 gas leak station. This is with the ones we integrated, the Itron radio that we demonstrated also at CES in January in their booth. And then in the middle, you have our, to give you a preview of what this box looks like and what is the form factor of it. We have the design, and you have the box, which is our connected outdoor air quality station that is done by eLikens. To conclude and give you a conclusion on that, so our technology and what eLikens does is really disruptive gas sensing solution to enable quite a few of these new upcoming smart city services. Us at eLikens and our solution are fully integrated now with Itron and SSN ecosystem, and we're actively pursuing sales opportunity in many different regions of the world and many different utilities and cities. To give you a couple of extra slides at the end and come back on time, everybody shows us what are some of the examples of air quality station usages within the city environment. So we try to expose some example of usage, but not limited to that, obviously, and what are the values. So detecting this microclimate detection with this hardware-assisted air quality station really enables you to do some new services and new functions, for example, redirecting traffic temporarily, and also or track pollution trajectory within the city if there are some events that they happen in that microclimate at that time of the day or of the week. Another example is building and using historic pollution data, and that allows you to, from a city standpoint or utilities or other feature functions you can roll out, really scheduling, for example, traffic management based on patterns and some historic data. On the gas leak detection is more self-explanatory, definitely safety and prevention and being able to detect high-risk events that can happen and lower disaster risks. That's another kind of example. Not limited to that, there are more and more applications that people are getting creative and coming up by using and taking advantage of the data available from pollution, air quality stations, and also gas leak detection. On the consumer side, one example of use case for such a data is really being able to show you the least polluted route. Today, for example, when you go from point A to point B, if you do map it, most options or one or two options they give you is based on speed and time of travel only. By having these kind of data associated, you get another level of information. And if it's an activity that is not just driving, if it's a day you want to walk, bike versus drive, then obviously you want to select and go through the route that is least polluted. So it brings you additional data even for your day-to-day usage from a consumer standpoint. Just some examples to show you what it looks like on these two slides. The output we covered earlier. This is the output of one station that gives you all the different sensor and output gases, and the historic data that is also available to all those APIs that you can utilize for any of your services or product designs. That's pretty much it. Try to bring it back on time and leave some time for questions at the end. So apologize it went a little bit fast, but Winston, if there are any questions, please let us know.
Yeah, we have one more question, and the question is, are your devices connecting in mesh topology or star topology?
We can do both, depending on the RF radio selected. We can do either of them. We are kind of, lack of a better term, agnostic on the RF front end. That's how we were able to utilize and work with many different flavors of Itron and Silver Spring Networks radio modules.
In the application
for
developed specifically on the Silver Spring network, it was connected in a leaf configuration. To answer the question specifically for the Silver Springs project.
And then next question as a follow-up is, are the units in the field, those that are installed in the field, what is the range of the unit communicating with the next neighboring unit in the mesh format?
That's a good question. I think I'm going to need some help from Todd on that, because that's more of a connectivity.
So yeah, so it's a standard milli module, but it depends, of course, on the antenna design. What the eLikens folks have done so far was just a standard milli, so it would be reasonably limited range of I don't know, hundreds of yards and half a mile kind of ranges on a milli device. And with a larger antenna, of course, you can push that out farther. But for what he's done so far, it was a limited antenna range.
Another question, is the eLikens solution integrated at the micro AP level or data platform level?
I'm not sure if I understand the question. By micro AP level
go back to your block diagram. To answer the question, they did not really use the data platform as storage. They had their own application, so they tried to pull data through the network, or they're pulling data through the network using the CoAP API to their own cloud application. Is that right?
Correct.
Is that right, Sam? Yeah.
That's correct. Exactly.
They use the network to get
the data
to
our, yes,
to their own application.
Our cloud, and we use that. Yep.
So that's all for the questions that have come in so far. Unless any attendees have final questions.
I saw one earlier. Can a Milli chip be used? Can a Milli 5 chip be used anywhere in the world? And the answer is yes, sort of. So a Milli, it can be used anywhere except for there's one separate SKU for Europe, which has the RED requirements. So there's a separate SKU. All of the European EU community countries have their own SKU. The regular milli that is, a normal milli can be used anywhere else outside of EU. Let's just put it that way, with the appropriate country code filters. And it's got limited FCC Part 15 certification approval in North America.
Okay, thanks, Todd. Looks like that's all for the audience questions. Thank you very much, Todd, and Sam as well from eLikens.
I do see Winston, I do see one or two more. I think we got a couple of minutes. You want to try to answer them? I think
okay.
There's one more here. All right. How many devices can piggyback on another device in mesh mode? You know, I've seen the answer to that question, and I actually don't recall. I don't actually recall. I'll get it for you and email it to you, though, Jay. So, how many devices can piggyback on another device in mesh mode? I'll find out for you. All right, that was it.
Okay.
Thank you.
Thank you very much to our guest speaker, Sam Meary from eLikens, and of course, Todd from Itron. If you're interested in viewing this on demand, we'll be sending it out via an email as a follow-up. I believe that goes out tomorrow, and we'll have this posted on our developer portal. So with that, we'll sign off. Thank you very much for attending.
Thank you. Bye-bye.